A very good day to you all grade 12 learners. Welcome to today's mathematical literacy lesson. My name is Mampani Kekana, and remember that this lesson is brought to you by the Gauteng Department of Education in collaboration with the Saibono Discovery Center. Now, boys and girls, we know that it is now a crunch time. I'm sure most of you might be done with the ATP, or you are busy finalizing the ATP with your educators. Very, 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 very important as you are preparing yourself for the prelim examination. And today we are going to focus on another interesting and a practical topic or section in mathematical literacy, which is packaging. I'm sure you might have already covered this with your educators, or you are busy with it. So I'm sure you are going to enjoy today's lesson. Now, as always, we start with the expectation. What must be learned in this lesson? What are the desired outcomes? The lesson outcomes in this section of packaging is, at the end of this lesson, you should be able to investigate. You should be able to investigate by making use of calculations with most cost-effective and most appropriate way to package cans or boxes for optimal use of space. Now, it's very, very important to understand the underlined words. What do we mean by most cost effective? Most cost effective is you need to try to spend less in order to use the space that you have. For instance, if you are doing packaging, you are trying by all means to use a small container to package a lot of content. Okay, if you need to package maybe cans into a bag, or you want to package cans into a box, make sure that whatever space that you have in the box, you'll be able to package a lot of tins, a lot of cans. And the appropriate way, remember, it is also very important. It's not only about the space, but it is also about the appropriate way. It's very important that whatever you're going to package, it's not being broken, okay, or it's not being squashed and so on. It's not being scratched and so on and so on. So the appropriate way, that one is also very, very important. Then the optimal use of space. So the optimal simply means you are going to use the space to the best of your ability. You're going to use the space to the best of your ability. Now, terminologies, boys and girls, are also very, very important in Maths Lit. And as we always say, whatever your teacher taught you in terms of terminologies, whatever way you find it easier to define it, as long as there's a couple of words, 4 to 5 words in your definition, as long as your definition is relevant, boys and girls, that is going to be acceptable. We do not expect every learner or different learners to write exactly the same definition. Now, in terms of terminologies, okay, of course, we need to understand what we mean by packaging, since we're going to do packaging. Now, what do we mean by packaging? Packaging is a process of packing items into a limited space. Process of packing items into a limited space. Okay, then we've got packaging arrangement. These are the models showing different ways in which items are arranged. Models showing different ways in which items are arranged. Okay, now when we do packaging, there are certain aspects that we need to take into consideration. Certain aspects that we need to take into consideration. In packaging, containers have different shapes. Okay, containers have different shapes. Like, for instance, if you're going to pack certain items into one box and they've got different shapes, how are you going to pack them? Is it going to be possible, or is it going to be easier to pack all the items of the same shape? Okay, so packaging containers have different shapes, and sizes because they are designed for specific purpose. And then we must also think about the following again: shape, okay, fragility. What do we mean by that? Fragility is something that can easily get broken. It can easily get broken. Think about a situation where you have to pack glasses into a box. Okay, you pack glasses into a box, and then if you don't pack them um, properly, they might get broken. And mass of a particular product. Okay, now remember, if you have to pack heavy stuff into a box, that can easily get broken. Okay, so you must also think about what you are going to pack into a container. Is the container going to be strong enough? Okay, can a particular product have an impact on the type of packaging container needed for that product? So these are some of the things that we need to take into consideration when we do packaging. And then the optimal usage of space. Okay, we don't want to waste space. Okay, if you've got a container and then you want to pack items into that container, we have to find a way that we use the space to the best of our ability. We don't waste any space. And then quantities of material. If we've got a container, what amount of material is going to be used? Okay, and then of course cost effectiveness. It means in this case we are trying to save. We want to use more space. Okay, more space in order to save money. Like for instance, you can just think about a situation where maybe you are moving and then you have to load a furniture into a truck. Okay, if for instance you are moving and you want to load a furniture into a truck, I don't think you want to have many trips. Okay, you want to try by all means to minimize the number of trips. You can see that, okay, with this furniture I can only maybe take 2 loads and then I'm done. And in 2 loads, it simply means it's going to be only 4 trips. Okay, but if you're not going to pack your furniture properly, if you're not going to pack it properly, it means you might end up not using the space properly. And what will that mean? That will mean you have to use a many trips. You'll have to take many trips in order to transport your furniture. So that is the same way. So we want to try by all means to use the space that we have to the best of ability so that we can actually uh, have less traveling or have less um, a number of teams, a number of trips. Okay, most appropriate way of packaging arrangement that uses the minimum amount of space to package the maximum number of items. Think about the space that you have. You want to load as many furniture items as possible. Cost-effective way of packaging. What do we mean by cost-effective way of packaging? Is packaging arrangement that uses the minimum amount of material. Okay, so if you've got a container, if you're using boxes, if you're working for, let's say for instance, you'll be working for a big company where you are doing packaging and so on, you want the containers that you're going to use. It means you mustn't waste the material to make those containers. Okay, so in this case we're going to use the smallest amount of material that we can in order to package as much items as possible. Now, in terms of packaging, boys and girls, we've got two methods. Okay, we've got two methods. We've got a practical method. Practical method, you will see as we do the calculations. Now, in practical method, we're going to use the two-dimensional diagrams or three-dimensional models of the scenario to evaluate the number of objects that may fit into a space. Okay, and then use length, breadth, height, and diameters. So for practical method, we're going to focus on the length, the breadth, the height, and the diameter of the items that we are going to pack, or maybe the containers that are going to be used to pack the items. The practical method caters, in other words, it takes into consideration for the gaps between the items to be packed. The method caters for gaps between the items to be packed. While we've got another method, which is a mathematical method, okay? This is not a favorable method, especially in our subject, okay? Because it is not practical. Use volume and surface area formulae to analyze the scenario. Use volume, surface area to analyze the scenario. The method does not consider that some items cannot be fit in the gap. Okay. Now, think about this, boys and girls. Let's say, for instance, they want to arrange tables and chairs for examination in your classroom. Okay. Obviously, with this mathematical method, what they will do is they will calculate the area of your classroom, and they calculate the area of the space that must be occupied by each learner. Okay, and then they take the area of the classroom and they divide it by the area of the space that must be occupied by the learner. But that method is not practical because it doesn't consider the spaces. It doesn't consider the space where maybe the invigilators will be able to move between the tables. Okay, it doesn't consider that space. So it also says that there shouldn't be any space between learners, and that is not possible. Okay, obviously when they pack tables, we expect that there must be at least a certain space between learners, and there must be a space where the invigilators will be able to move between the tables. Okay, so that will be the mathematical method. The mathematical method doesn't consider that. Okay, while the practical method actually considers the amount of space that must be left between the tables. Okay, now we are now going to look at the possible exam questions. That part was just an introduction. The concepts, very important to understand the concept and the terminologies. We're now going to look at the questions. So if you look at our first question, this was taken from Eastern Cape Grade 11 2018. Very important, you need to read and make sure that you understand the information that is given, boys and girls. In this case, is the builder wants to pave the carport using octagonal shape pavement bricks. Okay, octagonal, it just simply means it's a shape that has got 8 sides. Right? Shape pavement bricks. The dimensions of the carport are 500 centimeters by 300 centimeters. Now the dimensions, in this case, it simply means the carport it's a rectangular shape. If it's a rectangular shape, when they say the dimensions, they simply means the longer side is 500 centimeters and the shorter side is 300 centimeters. It simply means the length is 500 centimeters and the width is 300 centimeters. The picture alongside, which is actually the picture below, the picture alongside shows octagonal shaped. Remember I said octagonal, it means it has got 8 shapes. If you look at this, we've got 1 2 3 4 5 6 7 8. So it's 1 2 3 4 5 6 7 8. Octagonal simply means it has got 8 shapes. 8 sides. And then they say the picture alongside shows octagonal shaped paving bricks to be used as pavement. And then 1.1, they say determine the number of octagonal shaped pavement bricks to be used on the length of the carport. Determine the number of octagonal shaped pavement bricks to be used on the length of the carport. So in this case, let's say the longer side, it's this one, so it's 500 centimeters, and then we've got this one is 300 centimeters. Okay, never mind the picture. Okay, we are not going to look at the picture. If we had to look at the picture, it means we'll just count, but in this case we need to calculate. Now if you look at, if I have to redraw this, let's say, let me put it like this. I say, okay, this is 500 centimeters. That is for the longer side. Okay, of course it must look like, yes, it's a longer side. And then now I want to know this. If you look at the shape, it's like this. Okay, so now if I look at the wideness, the width of the brick, okay, the width of the brick, it's, in this case, it's indicated as 25 centimeters. So that is 25 centimeters. The width, okay, the wideness or the width of the brick is 25 centimeters. Now I want to check how many 25 centimeters will fit along the length. Okay, so for this one, they say determine the number of octagonal shaped pavement bricks. So the number will be 500 centimeters, because it must be along the length. 500 centimeters divided by 25 centimeters. Okay, I've actually tried to indicate the picture there, so forgive me, I'm not good in drawing, but I'm sure you get an idea. So what I will do, I'll take the length and then of the carport, and then I divide it by the width of the brick. So the width of the brick is 25 centimeters. So if I take 500 centimeters, I divide it by 25, 500 divided by 25, so it means 20 bricks. So this one is number of bricks lengthwise, or along the length. Okay, number of bricks lengthwise or along the brick, that is the number of bricks along the length, okay, or the number of bricks lengthwise. It's 500 centimeters divided by 25 centimeters, and that is 20. Okay, so that was question 1.1. Now for question 1.2, they say hence. Okay, the scenario is still the same, hence. And then remember, boys and girls, when a question starts with the word hence, when the question starts with the word hence, it simply means use the answer from the previous question, or use the information from the previous question. Okay, so hence determine the total number of octagonal shaped pavement bricks to be used on the carport. Okay, when I drew, I hope this time I'm going to draw it better than the other one. Okay, because the length and the breadth are not equal, so I will still say 500 centimeters, and this one is 300 centimeters. Okay, and then for this one, I had already indicated how many bricks will fit from one point to the other point. How many bricks will fit there? So we said lengthwise there's 20 of them. Now I want to know how many bricks will fit breadthwise, or the widthwise, along the width or along the breadth. The wideness or the width of the brick is the same. Okay, so if you look at this, you can see that it's still the same. So I want to know if this is 25. Okay, if this is 25, so now I want to know how many 25 centimeters are going to fit breadthwise. So we say number of bricks along the width. Okay, number of bricks along the width. So how do we calculate it? We take 300 centimeters, we divide it by 25 centimeters. So 300 divided by 25, so it's 300 divided by 25, then I get 12. Okay, so it simply means, remember that one we said 20, so it's about 20. I'm just going to indicate the circles. So here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, it must be 20. So it's 20 this way, and then it's going to be 12 this way. Okay, so it's 20 lengthwise and then 12 breadthwise. So if I have to calculate the number of bricks that will be needed, total will be equals to, now I take the previous one, remember we said it's, okay, if I take you back, we calculated 20. If I go to this one, I calculated 12. So this is just going to be 20 multiplied by 12, and this will give me the number of pavement bricks to be used on the carport. So it's 20 multiplied by 12, and then this is 240. So it's 240 bricks. So I just take the number of bricks that are going to fit lengthwise, and then I multiply by the number of bricks that are going to fit widthwise. Okay, so this is just 12 multiplied by, 20 multiplied by 12 is 240. So that was the first question. Okay, now this is the next question. It was taken from Western Cape, grade 12, 2023. It was a prelim examination. Now let us read the information. They say Koyasu Pharmacy in Tokyo offers delivery services to other pharmacies. The company uses two types of cars to deliver boxes to pharmacies within Tokyo. The boxes of one specific delivery are square-based with the dimensions as shown on the square. The square-based, now if you look at the box, there we've got the box. It shows that the height is 45 centimeters and then the breadth is 25 centimeters, but they say it is square base. That means the base, which is the bottom part, it's actually a square. It's in the form of a square shape. So if this is 25 centimeters, it simply means the other side is also 25 centimeters. The examiner didn't have to indicate it because the examiner indicated that this is a square based. Square based, it simply means the bottom part is actually in the form of a square shape. They say study the information above or study the information alongside and answer the questions that follow. Okay, now if you look at, we have already studied the box, and then they say the boot space. Okay, for Suzuki Espresso, they say it's 880 multiplied by 600 multiplied by 570. Okay, so in this 880, 600, and 570, the 880 is the length, and then the width is 600, and then the height is 570. Okay, then for Reynolds quit, you say it's 950. It simply means that 950 is the length, and then we've got 680. The 680 is the width, and we've got 530. That is the height of the Reynolds quit. Okay, so there we've got two different cars with different boot space. Okay, so that is, and then we are given, they say you may use the following. Volume is equals to length times width times height. Volume is equals to length times width times height. And then if we look at the boot space of Suzuki Espresso, okay, so there they are sort of giving you or show you how the shape of the boot looks like. So it's in the form of a rectangular shape. So it's sort of a rectangular prism. Okay, so that is how we study the information that is given. Now let us look at the questions. Then they say 2.1, explain the term capacity within the context. Explain the term capacity within the context. Now think about the term capacity in general. Okay. In general, the capacity is the amount of space. So the amount of space that, so in this case we say capacity, the amount of space inside the container, the amount of space inside the container. So, but in this case, it's going to be the amount of space inside the boot of a car. Okay, the amount of space, or the amount of space inside a boot of a car. So because we are looking at the amount of space, so this one is explain the term capacity within the context. It's amount of space inside the boot of a car. Okay, the amount of boot space of a car. Okay, that is how simple you can define it. Okay, then let us look at the next information. They say the Suzuki S Presso has a boot capacity of 300,960 centimeter cubed, or cubic centimeters. The salesman at Renault states that the boot capacity of the Renault Kwid is 41,400. Okay, so it's 41 million, sorry, 41,420,000 millimeter cubed, bigger than Suzuki Espresso. Verify showing all your calculations whether he is correct. Okay, so it's this one is 300,960 centimeter cubed. Okay, and then the salesman at the Renault states that the boot capacity of the Renault Kwid is 41,000 or 41,420,000 millimeter cubed bigger. Okay, so what does this mean? It simply means if you take the salesman at Renault states that the boot capacity of the Renault Kwid is 41,420,000 millimeter cubed. So what we are going to do is we have to calculate the difference of the capacities. Okay, for Suzuki Espresso, it's already given. So this one, it's already been calculated. But now we need to calculate the capacity of this one. So if we calculate the capacity, we need to check. For this one, I've got the volume is going to be length times breadth, or times width times height. I'm going to do the substitution. Okay, now if I do the substitution according to the given information, the Renault Kwid has got 950. The length of Renault Kwid is 950 millimeters. So it's 950. Okay, and then multiply by the width is 680, and the height is 530. Okay, the formula was given. This is the formula: the length times width times height. Now if we have to calculate the capacity, then now if you take your calculator, you say 950 multiply by 680 multiply by 530. This will give me a very, very big number. So let's see. I've got 1, 2, 3, 4, 5, 6. So this is 3, 4, 2. Okay. And then there's 380. 380. And then there's 000. Okay. This is what I'm getting on my calculator. I'm getting an answer with 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. You can also check with your calculator, boys and girls. 950 times 680 times 530, I get. So this number is, remember, the examiner might also ask you, especially with this type of numbers, to write it in weights. So this is 342,380,000. And remember, this is in millimeter cubed. Okay, and remember, this is for Renault Kwid. So I'm just going to say this is R, this is for RK. Okay, now from the information that is given, they say the salesman at the Reynolds states that the boot capacity of the Reynolds quilt is 41,420,000 millimeter cubed bigger. So it means it's bigger than the other one by 41,420,000 millimeter cubed. The difference simply means if I take the volume of the quilt and then I subtract the volume of the Suzuki Espresso, if I calculate the difference, the answer must be more than the answer must be 41,000 and 41,420,000. Okay, so the answer must be the sales at the Reynolds states that the boot capacity of the Reynolds quid is 41,000 bigger. So it means it's bigger than the other one by 41,420,000. Okay, do I know the volume of Suzuki Espresso? So for Suzuki Espresso, I've got volume equals to 300,960 cubic centimeters. Okay, now you need to be careful, boys and girls. You need to be careful. Can I subtract? Okay, can I subtract? No, I can't subtract because now the units are not the same. The units are not the same. So in order for me to subtract, I need to make the units to be the same. So for me to subtract, it means I need to change the centimeter cubed. I must change it to millimeter cubed. Okay, and then when I check from the given information, the conversion factor it's not given. The conversion factor unfortunately is not given. How do we convert from centimeter cubed to millimeter cubed? How do we convert from centimeter cubed to millimeter cubed? Now you need to be careful. We all know that 1 centimeter it's equals to 10 millimeters. Okay, 1 centimeter it's equals to 10 millimeters. Now what some of you tend to do in this case, you tend to think that even if it's centimeter cubed, when I change the centimeter cubed to millimeter cubed, then I will multiply by 10. But remember, this one is just a centimeter to a millimeter. There's no square there, there's no cube. Okay, so this is for converting a length. Okay, but in this case I want to convert a cubic centimeter. Now I have to check if I change this to a cube. Okay, a cube, you did the cubes in grade 10. If I say 1 to the power of 3, I get 1, and this will give me 1 centimeter cubed. Okay, and then this is equals to, if I say 10 to the power of 3, 10 to the power of 3 must give you 1,000. Okay, if you check on your calculator, I'm sure you know how to do the powers. It must give you 1,000 millimeter cube. That's why you had to do the cubes in grade 10. So 1 cubic centimeter is equals to 1,000 millimeter cubed. So what do I do in this case? It simply means if I want to convert from a cubic centimeter to a cubic millimeter, I must multiply by 1,000. Okay, so I must multiply by 1,000. Here I've got cubic centimeter. So I'll say, therefore, this is V of volume equals to 300,960 multiplied by 1,000. And it's now going to be millimeter cubed. Then if I do this, then it's going to give me 300,960,000 millimeter cubed. Now this is the volume for S. I'll just say SS. Suzuki Espresso. This is the volume of Suzuki Espresso, and this is the volume of Reynolds Quid. Okay, now I have to check the difference. Simply means if I work out the difference, so let's check the difference. If I take the volume, if I take the bigger one, in this case the big one it's 342 380 000. Okay, 342,380,000. Now I subtract 300,960,000. Okay, let's see. Okay, we want to check if the difference is 41,420. Now, if I take my calculator, I say 342 380 000. Okay, 342,380,000 minus 300,960,000. Okay, actually 300,960,000. 300,960,000. So the answer that I'm getting is I'm getting 41420 000. Okay, you need to be very careful, boys and girls, because here we are working with very, very, very big numbers. It's not that easy. We are working with very, very big numbers. Now, if I calculate the difference, 342 380 000, 342,380,000 minus 300,960,000. The answer that I'm getting is 41,420,000. And remember, this is in cubic meters. So it means if I calculate the difference of the capacities, if I calculate the difference of the volumes, this is what I'm getting. So it simply means the Ronald Quid has got a bigger boot capacity. Ronald Quid has got a bigger boot capacity than Suzuki Espresso. So the examiner here was saying, verify showing all your calculations whether he's correct. So in this case, you can say he is correct. Very important to indicate that statement. He is correct. But remember, the statement goes with the calculations. If you don't do the calculations and then you just write down the statement, you won't get any mark. So you just have to do the calculations first. Okay, it's a very long one. It deals with big numbers, so it needs a lot of patience. Okay, it needs a lot of patience, and you also need to be careful with your calculations. But that is how long it is, and that is how long it is. But in the end, the answer, we could verify that indeed the salesman at Ronald was correct. He was not just selling the car, he was not just advertising the car, but his mathematics in terms of capacity was based on facts. Okay, that is the question. Right. Then number 2.3, it says, calculate the number of boxes that will be able to fit into a Suzuki Espresso if the boxes are to be packed upright. Okay, calculate the number of boxes that will be able to fit into the Suzuki Espresso. Okay, now if we look at the Suzuki Espresso, is this one. Let me draw. I hope I'll be able to draw. I'm not good in drawing. So I'll indicate. Okay, that is my rectangular prism. Okay, they say the boot of the Suzuki Espresso, it's a rectangular prism as indicated. It's a rectangular prism as indicated there. Then on this one, they say the length is 880 millimeters. And then I've got the width. Okay, in this case, the width, they say it's 600. So this side is 600 millimeters. And then now I've got the height, which is this one. The height is for Suzuki Espresso is 570. Okay, remember we are going to use a mathematical method. Okay, now remember this is now the boot of the Suzuki Espresso. I need to pack these boxes, and these boxes must be upright. Okay, so now I'll need to check how many of these boxes are going to fit into this into the boot, which is in the form of a rectangular shape. Now I'm going to check the number, let's say along the length. So I'll say number of boxes along the length. Okay, along the length, it's going to be, now I must take the length of the boot, and then I must divide it by the length of the box. Okay, so in this case, I've got 880 millimeters, which must be divided by 25 centimeters. Okay, I've got 880 millimeters, and then I must divide it by 25 centimeters. Now you need to be careful, boys and girls. You need to be careful. Look at the division. There I've got a millimeter, and there I've got a centimeter. Okay, if you are still struggling with basic conversion, the basic conversion, it's actually the foundation of everything in paper 2. Okay, the basic conversion, converting between metric units, it is the basic foundation. If you are still struggling, if you still don't know how many centimeters equals to meters, how many millimeters equals to centimeters, how many kilometers equals to meters, if you're still struggling with that, boys and girls, I promise you, you are going to struggle with a lot of questions, if not all of them, in paper 2. So please make sure that the basic conversion, you master it. Make sure that you grasp that concept of the basic conversion, because you are going to use it in most of the calculations in paper 2. Now, if you look at this one, we need to divide. 808 we need to divide. We can only divide if the units are the same. So what do we do in this case? It's 880 millimeters. Let's convert centimeters to millimeters. Think about the edge of your ruler, especially with centimeter and millimeters. You will see on the other side, if it's 1 centimeter, and then on the millimeter side is 10 millimeters. So it simply means 1 centimeter is the same as 10 millimeters. How do we convert from centimeters to millimeters? We multiply by 10. So this will be 880 millimeters. Then we say over 25 multiplied by 10. So this is the same as 250 millimeters. If I take that 25, I multiply by 10, I'm converting it to millimeters. Then now I can check, I can say 880 divided by 250. 880 divided by 250, then I get 3.52. 3.52. Okay, now if it's 3.52, it means the number of boxes that are going to fit along the length, the number of boxes that are going to fit along the length, it's 3.52, but we don't have a fraction of the box. Think about this. If we have to round it off, the answer is supposed to be 4. Okay, but we are not rounding off in packaging. Okay, we're always rounding down. So the answer in this case will be 3. Okay, if we have to say 4, the fourth one will not have enough space to fit there. So that is why we're always rounding it down. So the number of boxes along the length, it's going to be 3. Okay, now let's check along the width. Now this is along the width. So we say the number of boxes Again, number of boxes. So I'm done with this. Number of boxes along the width. Still the same procedure. I have to look at the width. The width is 600 millimeters, and then I divide it by, okay, I have to look at the width of the box. If you look at the box, we said the length is 25, and then remember they said it's a square based, so it means the length and the width are the same. The length and the width are the same. So in this case, the width will also be divided by 25 centimeters. But remember, I've already done the conversion. You know that this is the same as 600 millimeters divided by 250 millimeters. Okay, and this will give me the number of boxes that are going to fit the breadth wise or the width wise. So for the width wise, it's 600 divided by 250, and then this gives me 2.4. So it's 2.4, then this will give me 2. I'll also round it down. The number of boxes that are going to fit width-wise, it's 2. Now I have to check the height-wise. So for the height-wise, I say number of boxes along the height. The number of boxes along the height. The height is 570 millimeters. Then I divide it by, if you look at the height of the box, it's 45 centimeters. Don't make a mistake. 45 centimeters. The same procedure. We can't divide the millimeters and centimeters, so we have to make sure that they are the same. How do I convert? In this case, I can convert the 45 centimeters to millimeters. How do we convert from centimeters to millimeters? Again, we multiply by 10. Okay, so this is the same as 570 millimeters divided by 450 millimeters, because if I convert from a centimeter to millimeter, I multiply by 10. 45 multiplied by 10 is 450, and this will give me, take your calculator, 570 divided by 450, then I get on my calculator 1,26, 1,2666, and so on and so on. So this will be 1. So for the height wise, I can only put 1 box. Okay, right. Then the question was, calculate the number of boxes that will be able to fit into the Suzuki Espresso if the boxes are packed upright. So upright, then what do? I say the number of boxes that they are going to fit along the length, which is 3. Number of boxes, or total number of boxes. Total number of boxes will give me, I take 3, I multiply by 2, and then I multiply by 1. Okay, so it's 3 multiplied by 2 multiplied by 1, then the answer is 6. Okay, it's also quite a lengthy one, but you need to be patient, and then you need to be careful with your calculations. Hence I said conversion, it's the core of this type of questions as well. Actually, you can think of any question in paper 2, okay, or you can think of many questions in paper 2. Conversion. Very, very important. So this is the answer for question 2.3. Okay, let's see if we can get to the next question. Okay, yeah, so that was question 2.3, and then the next question is question 3. Now, question 3, a tin of coffee has a diameter of 100 millimeters, okay, as indicated on the picture as well. and a height of 120 millimeters. There's 120 millimeters, and then the diameter is indeed 100 millimeters. A cardboard box is 500 millimeters long, 300 millimeters wide. That means the width is 300 millimeters and 240 millimeters high. Study the diagram alongside. There's the diagram, and answer the questions that follow. So we just study it. We check if whatever is given in words, it also appears on the pictures. Okay, indeed, the dimensions of the rectangle, the length is 500 millimeters, the width is 300 millimeters, and the height is 240. Now, determine the maximum number of tins that can be packed into the cardboard. Determine the number of tins that can be packed in the card box. Okay, so in this case, obviously, the tins will have to be packed upright. Okay, will have to be packed upright. Now let's see. If you look at this tin is 100 millimeters. Now, if we have to take this tin and pack it along the 500 millimeters, we are going to check how wide the tin is. How wide the tin is. Okay, so then that will be determined by the diameter. Then we need to check how many diameters are going to fit there. How many 100 millimeters are going to fit there? So we say, right, number of tins, okay, along the length. It's 500 millimeters. And then we divide it by 100 millimeters. Luckily, in this case, the division, the units are the same. We don't have to convert, unlike the previous one. The previous one, the units were not the same. So if I say 500 divided by 100, then I get 5. So the number of tins from this point to that point, the number of tins that will fit there is 5. Then I have to check on the other side. Okay, I'm sure all of you can see the answer already. So, but you must write it down. The number of tins along the width, it's 300 millimeters. Then we divide it by 100 as well, because we also need the wideness or the width. In this case, how wide the tin is, that is determined by the diameter. So the diameter is still 100. So it's 300 divided by 100 millimeters. So luckily, we don't have to change any unit, and this one is just 3. Okay, then we now have to check the height wise. Okay, how many tins can be stacked together? Okay, so in this case, we look at the height, and we are also going to look at the height of the tin. Okay, so number of tins along the height. Now, along the height, we just take 240 millimeters. We divide it by 120. So 240 divided by 120. If you take 240 divided by 120, it must give you, of course, 2. So the answer there is 2. I'm just going to indicate it there. Okay, so it means we can have actually 2 layers. Okay, the first layer and the second layer, because 2 tins can be stacked on each other. Okay, so the total number of tins in this case, we say total is 5 multiplied by 3 and then multiplied by 2. It's equals to 5 times 3 times 2. So 5 times 3, it's 15. 10 times 2 is 30. Okay. So the total number of tins that will fit in this box, it's 30. Boys and girls, this is a practical method. If you have to see the mathematical method, the mathematical method doesn't give you the correct answers. So you must just be careful. Just make sure that you don't even use that method in the examination. I can just give you an example with this one. Okay, just for us to compare the answers. The mathematical method in this case, it simply means you'll take the volume. You'll take the volume of the box and you divide it by the volume of the tin. We can quickly do that. If I look at the volume of the box will be 300 multiplied by 500. Okay, or anyway, but it must be the length times breadth times height. I just want to do it in the correct order. Then the length is 500, the breadth is 300, the height is 240. So if I calculate the volume of the box, I get 500 multiplied by 300 and multiplied by 240. That is 360. 300. Let me see. 1, 2, 3, 4, 5, 6. So it's 36 million. 36 million. Okay. Then if I calculate the volume of the tin, we know the formula for calculating a cylinder is V equals to pi r squared h. So it's 3,142. And my radius in this case will be 100 divided by 2. So that will be 50. 50 squared. Okay. So, and then the height is 120. So it's 120. So if I simplify that, I say 3,142 and then I multiply by 50 squared. Okay, then I multiply by 50 squared, I multiply by 120. Then I get 9, 4, 2, 600. Okay, then if I divide, I say 3, 6, 000, 000. Okay, then I divide it by 9, 4, 2, 600. Okay, it gives me 38. So in other words, what we will do in this case is, this is a mathematical method. We'll say, now if I calculate the volume, okay, the volume of the box, which is 36 million, but when I calculate the volume of the tin, I get 942,600. Then I want to know how many tins will fit into the box. Then I just take the volume of the box, I divide it by the volume of the tin. But if I take this, if I take 3, 6, 000, and then I divide it by 942, 600. Okay, the answer that I'm getting is 38. 38,1 and so on. But since we are talking about the number of items, this will be about 38. Can you see that if you are using the mathematical method, I'm getting more. It's 38. And this one I'm getting 30. But this one simply means the tins. Remember, when you pack the tins into the box, if you pack them, they are in circular form, circular form, circular form, and so on. Circular form, circular form, circular form. Can you see that there's going to be spaces there? There's going to be spaces there, okay? But this one doesn't take that space into consideration, okay? It doesn't cater that space. Okay, so that is why at the end of the day, this one will say, well, we can pack more tins, because it doesn't cater the space. That if I pack, once I pack them, there isn't actually going to be, once I pack them, there's actually going to be spaces in between. Okay, so in this case, it means there's no spaces. So whenever we have to determine the maximum number, or whenever we have to determine the number, we mustn't use this method. Okay, we mustn't use that method. We must use the practical method where we are using the length, where we are using the breadth, where we are using the height, where we are using the diameter if possible. Okay, no shortcut, because the shortcut it's actually not practical. So I was just giving you an idea in terms of, because remember at the beginning we spoke about a mathematical method and a practical method. So our focus is only on practical method, only on practical method. Okay, but in this case, I was just trying to show you that actually the mathematical method, why the mathematical method is wrong. Okay, because in this case it gives us an impression that we can actually pack more tins, but that is actually not the case. Right. Another similar question is, Vuyo bought tuna in bulk from a factory shop at a very good price. He wants to send some of it to his sister. Look at the drawings alongside, not drawn to scale, and answer the questions that follow. 4.1. How many tuna tins can Vuyo pack across the length of the box? I think this one they are making it much easier because you just need to calculate. So let's see. Along the length, so we say number of tins, you don't even have to indicate along the length because already it's along the length for this question. We take the length of the box, which is 48 centimeters. Then we need to divide it by the wideness, the width of the tuna tin. Okay, so if you look at the tuna tin, is from this point to that point. But the measurement, the only dimension that is given there, it's the radius. They say it's 4.2. So this one is 4.2, but obviously we don't need 4.2. We need the whole width. The whole width. We need the diameter. So this must be 4.2 times 2. So 4.2 times 2, it must give us 8.4. 4.2 times 2 then is 8.4. Is it also in centimeters? Yes, it's in centimeters. So we're going to use the diameter of the tuna tin. Okay, so in this case, the number of tins is 48, and then we divide it by 8.4 centimeters. Then we say 48 divided by 8.4, 8.4, and then we get 5.7. 5.7. No, there's no unit. Be careful. It's just the number of tins. So we get 5.7. But remember, we say we don't round it off, we round it down. If we have to round it off, it's going to be 6. Okay, and then it simply means the sixth tin would not have enough space. So therefore, that is why we're going to have enough space for 5 tins. So in this case, we round it down. Okay, that is 4.1. And then for 4.2, it says how many tuna tins can Vuyo pack across the width. That's why I said boys and girls, in this case the examiner actually made it easier for the learners, because it's just everything that we did in the previous questions, everything that we did in one question, but in this case the questions have been separated. So the number of tins, we can still just indicate number of tins. The width wise is 35 centimeters, and then we still divide it by the radius. No, we don't divide it by the radius, but we divide it by the diameter. And remember, the diameter we said is 8.4 centimeters. 8.4 centimeters. Both of them are now the same unit. If you take your calculator, 35 divided by 8.4, and then we get 4.1666 on your calculator. You need to check it as well. And then from this one, I round it down, and then it becomes 4. So rounding off and rounding down, in this case, they'll give me the same answer, but the focus is about rounding down. So the number of tins, the width wise, it's 4. That's how easy it is. And then the Next question, 4.3. How many tuna tins can Vuyo stack on top of each other? Stack on top of each other. Okay, so this one is number of tins, height, or along the height. Number of tins. Okay, we take the height of the box, which is 15 centimeters. So it's 15 centimeters. We divide it by the height of the tuna tin, so which is 3.8 centimeters. 3.8 centimeters. In this case, we don't have to convert any unit because the units are the same. So if you use a calculator, okay, so if you use a calculator, we get 15 divided by 3.8. Then I get 3.9. 3.9473 and so on. Don't get tempted. We are not rounding off. Okay, 3.9, if you round it off, it must be 4. But in this case, if we have to pack 4 on top of each other, it simply means the fourth one is not going to have enough space. If we have to close the box, we won't be able to close the box. Okay, so in this case, say only 3. Okay, only 3 can be stacked on top of each other. So that is the answer for 4.3. Sorry. Then the next question is, Buyo claims that he can get more than 50 tuna tins packed in the box. Show with necessary calculations whether his statement is true. So the total will be, okay, the total will be, if we go back to the first question, okay, the first one we had 5. So it's 5 times 4. Okay, that is the first layer. 5 times 4 and then times 3. 5 times 4 times 3. So 5 times 4 times 3. That is the answer that we got in 4.1. Multiply by the answer that we got in 4.2. Multiply by the answer that we got in 4.3. So if I calculate this, 5 times 4 is 20, and then 20 times 3 is 60. Okay, so we can see that in this case, 60 tuna tins can be packed. Okay, let's go back to our question where they say Vuyo claims that they can get more than 50 tuna tins packed in the box. Show with the necessary calculation whether his statement is true. Then we can see that his statement is true. It's very important that you write it down. When we did the calculation, you can see that 60 is more than 50. Even if it was just 51, even if it was just 52, 53, 54, but it means his statement is true. Okay, so that is how easy this question is. Right, and then the next question, you'll see that this is actually similar to the previous ones. 5-liter paint tins are packed in shops for delivery in big rectangular boxes. An example of these boxes are shown below or alongside. The diagram are not drawn to scale. Okay, so the size does not matter there. The packers argue that if they use box A for packing the paint tins, they will be able to pack more than 2 times the paint tins in box B. Okay, so according to them, they say they will be able to pack more than 2 times the paint tins. Okay, so in other words, according to them, box A, okay, will have the number of tins that are 2 times that will be in box B. Okay, so it means, for instance, if box B has got 10, that one is going to have 20. If this one has got 30, that one is going to have, actually they say more than that. Okay, so let us quickly do the calculation since the time is not on our side. Now, if I use this one, so this is the length and that is the breadth. Okay, and then that is the height. And then there we've got the dimensions of the tin. So for box A, I'm going to do it like this. So for the length, okay, for the length, I'm going to have 130 centimeters divided by, if you look at the dimensions of the tin, it's the radius is 9 centimeters. There it's indicated. The radius is 9 centimeters. So, but in this case, I'm not going to use the radius. I have to use the diameter. Okay, because it is that wideness or that width or the diameter of the tin that is going to occupy that space. So it's 130. So the diameter in this case, remember this is something that you need to know. The diameter is 9 times 2. So this will give me 18 centimeters. So the diameter of the tin is 18 centimeters. So I say divide by 18 centimeters. Then this will give me 130 divided by 18. So it's 7.2. So I'm going to write 7.2, which is 7. Okay. And then for the breadth, so for the breadth, it's going to be, what is that? 104 divided by 18 centimeters divided by 18. So 104 divided by 18, and this will give me 5.7. Now remember, if it's 5.7, I round it down, it must be 5. Okay, then for the height, I'm going to take 25 centimeters. I divided by, let's see, 25 centimeters of the box, and then I divided by 24. So 25 divided by 25 divided by 24, then I get 1.04, 1.04, which is actually 1. Then from this one, you can see how many boxes will fit in box A. The number of boxes in this case is going to be 7 times 5 times 1. So 7 times 5, 7 times 5 is 35. So 35 boxes will fit in box A. Then we have to do the same thing with box B. Then box B, I'm going to indicate it here. Okay, for length, it's going to be 65. We still divided by 18. So 65 divided by 18, 65 divided by 18, this will give me about 3.6. So 3.6, I'm going to write 3. Okay, and then breadth, okay, it's 52. So 52 divided by 18. Okay, I don't have enough space there, so I'm just going to say 52 divided by 18. Then I get 2.8, but 2.8 I can't write 3, so I have to write 2. And then for the height, remember this is the breadth. Okay, and then for the height, okay, let me separate this. For the height is 49. 49 divided by 18. So, okay, 49 divided by 18, it's 2.7, but I'm not going to write 2.7, I'm going to write 2. So 2. So what does this mean? It means box B. Box B, it's going to be 3 times 2 times 2. So it's 3 times 2, which is 6. 6 times 2 is 12. So this one can take 12, and this one can take 35. Okay, the question or the information that is given there is the packers argue that if they use box A for packaging the paintings, they will be able to pack more than two times. So it means here I've got 35. For this one, I've got 12. If I take this one, I multiply by 2, it will still be less than that one. Okay, 35. If I take 12, I multiply by 2, it will still be okay. So this one, this box A can actually take box A for packet. They'll be able to pack more than two times what will be in. So 2 times what is in box B is going to be 24, and in this case I've got 35. Okay, so their argument is valid. So you need to write it, indicate it somewhere that their argument is valid. Very important that you must indicate it at the end of your calculations. Okay, because the examiner will say to prove if the argument is valid or not, you have to indicate based on your answer. Okay, now boys and girls, this is how easy the packaging or calculations that are based on packaging is. This is very, very, very easy. Okay, you can actually score a lot of marks in this case. Okay, remember, no mathematical method, but it's only a practical method. Mathematical method, that means it's where you are using a volume, okay, or you are using an area. Okay, you take the area of the container, you divide it by the area of the content, what must be packed in. Okay, or you take the volume of the container, you divide it by the volume of what must be packed in. Okay, so that is wrong, forget about that one. This is one way of doing it. Okay, this is one way of doing it. So very, very important that you need to use the mathematical method. Boys and girls, unfortunately time is not on our side, so I hope you have enjoyed today's lesson. By so doing, this will bring us to the end of our today's lesson, and then we thank you very much for watching the lesson. Until we see you next time, all the best. Goodbye.